In this video we'll talk about powers in scientific notation. When we talk about powers, it's a base raised to an exponent. We state a to the bth power or a raised to the b. When we have a positive b, that means we're going to take our base and multiply it by itself b times. So 4 to the fifth would be 4 times 4 times 4 times 4 times 4. 4 multiplied by itself 5 times. Now, when I have a negative b, that means I need to take my base and turn it into a fraction, 1 over my base. So when I have 4 raised to the negative fifth, that becomes 1/4 times 1/4 times 1/4 times 1/4 times 1/4. So there's the big difference. Pay attention, positive and negative exponents. And then if my exponent is 0, anything raised to the 0 power is always 1. So 7 raised to 0 is 1. Now this is very helpful when we look at 10 as our base and it's raised to a power, because all that happens is we shift our decimal place depending on what we're being raised to, because it's 10 times 10 times 10. We know that just shifts decimal places. So if I look here, I got 10 to the fourth, 4 zeros, 10 to the third, I got 3 zeros, 10 to the second, 2 zeros, 10 to the first is just 10, 10 to the 0, always anything is 1, and that helps make sense too, because then it's that decimal place that's shifting one at a time, and you can see how it shifts as I go into my negatives as well. Now scientific notation, this is where that 10 raised to a power is very helpful, because we can express large and small numbers in a way that's more meaningful. And with the scientific notation, we have exactly one digit that's non-zero to the left of the decimal place, and then that value is multiplied by 10 raised to a power. So let's look at these numbers and say, are they in scientific notation? 9 and 42 hundredths times 10 to the third? Yes, because there's only one non-zero digit to the left. 13 and 7 tenths times 10 to the negative 8? No, because there's 2 digits to the left and we can only have one. 56 hundredths times 10 to the 6? No, because there's no non-zero digit. It should be 5 and 6 tenths times 10 to the fifth. 3 and 2 tenths times 10 to the negative fifth? Yes, only one non-zero digit to the left. We can have a negative exponent, that's fine. Negative 4 and 712 thousandths times 10 to the ninth? Yes, even though this value is negative, that's okay, because I can have large negative values. And negative 12 and 32 hundredths times 10 to the negative 15th? No, because there's 2 digits to the left of the decimal. The negative is fine. Now when we want to convert to scientific notation, we begin with any number. Say I have 923,457. I'm going to determine where is my decimal point, and in this case, it's to the right of the 7. Next I'm going to move it until there's only one non-zero digit to the left, and I'm going to count how many digits I pass. So I go 1, 2, 3, 4, I pass 5 digits. And that's important because when I do my power for 10, it's based on the number of digits I passed. I went to the left, so it's going to be a positive exponent. So 9 and 223,457 hundred thousandths times 10 to the fifth. Now, say I've got 365 hundred thousandths, and I want to move my decimal place, and I already know where my decimal place is. I gotta move it so there's one non-zero digit, so it goes 1, 2, 3. So now I have 3 and 65 hundredths times 10, and I pass 3 values, so that's a negative 3.